What are we going to talk about today? I'm going to take you briefly through what a railway earthwork is, how they can behave, what kind of monitoring systems we use to look after them, what kind of remediation works we employ, and then we're going to talk you through a couple of case studies. So what is a railway earthwork? I'm sure you're all aware we want to have railways at a level. When they build through a landscape, they had to build up for embankments and cut through the hillsides to make cuttings. These days, when you want to build an embankment, you use good quality fill, you put it down in layers and you compact it, and in advance of any of that work you prepare the ground so you've got a nice solid and stable embankment. We've seen this picture earlier today. That's how we built our embankments that we're currently running our trains on. The railway engineers who built it did some amazing things, but they didn't know what they were doing with soil mechanics. So they used the spoil from nearby cuttings, dumped it in here and left it settle on its own. When it settled a bit too much or you had little slips, you just threw more ash or fill on it. So what can go wrong with earthworks? Settlement is one of the big ones, ongoing settlement. You get settlement of the underlying natural ground, so things like peats, alluvium, clays and silts. So the whole embankment just sinks. You can get this, which is the embankment material itself self-compacts. So you get both end up with loss of cess and drop in rails. You can get impact of trees, can cause shrink swell behaviour, which was mentioned earlier today. Burrowing animals is a particularly nice picture of what rabbits can do to our embankments. You can get this kind of translational failure, which tends to be a shallow slip and a nice smooth surface like that. You get rotational failure, where you can see just where that group of people are standing. There's the start of a back scar. Oh, hang on, I think I can do this. There, like that. Start of a back scar going into the embankment itself. Earth flow, where you get water building up behind the embankment, flowing through the embankment itself and washing fines out, eventually completely undermining. This is washout. So in this particular case, there was water, huge amounts of water, came through the cutting here and exited at the first available point, washing out the embankment. And you can get scour. So many of these things are related to drainage. Cutting failures, that's a small translational slip. You can see the back scar up the top. It's not doing much movement, it's only a small little bit. It's a bit bigger, rotational slip through a hillside. That one was from Scotland. You'll all recognise that one. Magnificent failure at Hatfield. Big rotational slip, pushed everything up. You can get washout in cuttings. So again, this one, huge amounts of water coming down this field, built up behind that stone wall and burst through it, washing out the weathered, so there's weathered rock on the surface, kind of weathered to a soil, and that got washed out onto the track, and that photograph of it is after it's been cleaned up. This is earth flow in a cutting, so where you get essentially groundwater exiting in the face of a cutting and washing material out with it. This one is another picture of earth flow. Rockfall, one of my favourites. This one is from clay cross cutting, you might be familiar with it. There is a block in the 6 foot and a block in the cess, and it's come from up there. Burrowing animals, so despite the best efforts of the off-track team, putting in this wall, trying to stop this spoil reaching the cess, it's now filled it up and it's coming in again. So what are the impacts of earthworks failures? I mentioned earlier about what happens when you get settlement. We lose the shoulder, can cause problems in hot weather preparedness. You can get track problems themselves. Lineside assets can start falling over, and you get very thick ballast from successive track lifts. That's a picture up near Morpeth, which is a nice embankment slip going across all of the lines. This is one you may recognise from Unston, where you have a rotational slip pushing the track up and it's pushing everything over. This one is Barrow-on-Soar. So this particular location was the site of Poor Top, which eventually, over Christmas time, 2012, 2013 I think, developed into a full slip there was large amounts of water ponding at the toe of the embankment. This is a washout that happened fairly recently, actually up near where we are, and we've got some blocks coming from the limestone cutting, but also lots of straw coming down from the fields. This site is at Clare and caused this. In this particular site, again, it was during a huge rainfall event. Water came down here and came over the side, and this cutting is made of Mercia mudstone, and it had, in this top corner, it had completely weathered to it was just mush, and the whole lot came down, and that wouldn't have been so bad, but there were some tree stumps in there, so the tree stump came down and was hit by the train and was derailed. So why do we monitor earthworks? So first of all, we need to know if that's going to happen. We need to know if that's going to happen, if we're going to get our tracks being pushed up, or if we're going to lose support to the track in an embankment. So those are the main reasons, those are the operational reasons we monitor earthworks. Then there are some geotechnical reasons where we want to better understand the ground. So in order to do that, we will often put in boreholes, we'll drill some boreholes, put some instruments in there, take samples of the type of material, what strength it is, and then these inclinometers we put down through here, and as we take measurements over time, over a period of months, hopefully months and not days, you start to see evidence of where the slip surface is, and you can start to build up a ground model, and with that ground model you can start working out how you're going to fix it, what's the best way of fixing it. So how do we monitor earthworks? Our first and most basic way of monitoring earthworks is to do our earthworks examinations. We do walkover surveys during the winter months when vegetation is low. Our examiners look for things like bulges, scarring, bent vegetation, loss of support of the troughing, that kind of thing. They'll look for this, obviously, for track faults. And this is the handheld device which was mentioned earlier that Martin helped trial many years ago, this gizmo device. And so our examiners go out, they take all this information in and press a button, and an algorithm sits in the background and out pops a score. Oh yeah, so they also look for this. So we've got loss of ballast here around the sleeper ends. We've also got severe loss of ballast in the 6 foot. The examiners, they get a score that comes out from their earthworks exams, and anything that scores highly is looked at by our team, the asset management team. So we do what we call an evaluation. As part of that evaluation, I'll try and look at the track records if I can. When I started these evaluations about 7 years ago, I had no direct access to get any of this information, so I would get in touch with the track maintainer by email or phone and say, look, I've got this embankment, I think it's a bit dodgy. Are you having track problems? And they may or may not get back to me. And that was as much as I was able to do. And then a couple of years later, I got access to the traces. I was delighted with myself. I had these traces, I had these little CCQ charts, and I was able to look at it myself. And then a couple of years after that, I got access to the ellipse maintenance records. Again, delighted with myself, thinking brilliant. Using section managers, track walkers, the track maintainer, new measurement data. Oh yeah, looking for rough rides is the other thing we look at. But then we got LADS, which I think is amazing. It has definitely revolutionised how I work in terms of looking at embankments and making decisions about whether we're going to do physical works or not. How do we use LADS? So I've got a big long embankment here. It looks like this. That's what it looks like when you're out on site. I know there's some problems there, but I don't know exactly what's going on. It looks pretty similar the whole way along. I get my LADS data. I use my little crib sheet about what the codes stand for. These frequent track faults are thought to be underlying ground conditions. So as part of my remit to our contractor and our designers, I give them this information. They'll go and verify it on site, but it's a really good start for me. So I can then split my site up into these red bits I'm spending a lot of money on, the orange bits medium, and The yellow bits are maintain sites. So it helps me focus my money. How do we use lads better? Please, if the track teams identify where they're physically doing works, it would make a huge difference to me. That makes it look as if they're manually correcting between 0 miles and 30 miles, and I know they're not.